How big of a water bucket do you need to put out the sun? How would Earth look like from another galaxy? Will the moon stay tidally locked forever? Why is Uranus so hilarious? And in Q&A Plus, which cinematic cliches deserve to be thrown out the airlock? All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Kevin Patrick, why is Uranus the butt of all jokes in the solar system? Because saying the word Uranus in English sounds like your anus, which is person's butthole. And that's hilarious when you've got, on the one hand, the rigorous scientific discipline of planetary science, and on the other hand, you've got poopy farts. And they come together in this sort of difficult merging in your brain. And you have to sort of, on the one hand, be awed by the majesty of a world covered in ice and rock that has barely been explored by only one of our spacecraft. And on the other hand, it sounds like butts. That's so funny. SSA Laura. Our moon is tidally locked and moving away from us. Will it remain tidally locked forever? What happens if it gets too far away from Earth? Will it fly off into space? So the moon is tidally locked to the Earth, and the Earth is not tidally locked to the moon. So the moon takes about 28 days to complete one orbit around the Earth, and it takes about 28 days to complete one turn on its axis. And so from our perspective on the surface of the Earth, we see the same side of the moon throughout its entire orbit, and always have, and always will. But we are still rotating, and that this early on in the history of the Earth and the moon, this wasn't the case, that the moon was turning, the Earth was turning, but tidal forces always inexorably push towards this process where things lock together. The moon has less mass, it is smaller, and so it was able to lock to the Earth first. But this process is still continuing with the Earth, which is that the moon is trying to lock the Earth to the moon and slow down the Earth's rotation. And then as a result, for conservation of momentum, this causes the moon to drift away. And so what you get is that the Earth's day rate gets longer, the moon gets farther, and eventually the Earth and the moon will lock to each other. The Earth will only show the same face to the moon. The moon will only show the same face to the Earth. The moon will stop drifting farther away from us. And that will happen in about 50 billion years. So long after the sun has died, probably consumed the inner planets, maybe even the Earth. And so it's kind of a moot point. What will happen when the Earth locks to the moon? The Earth and the moon will have been destroyed by the sun in some way, by it turning into a red giant. Or not. But but that process will continue on. Ste B, how large would a bucket of water have to be to put out the sun? So you can't put out the sun by throwing water on the sun, because the problem is that if you feed water to the sun, water is made of hydrogen and oxygen, it would heat up and would break into plasma of oxygen and hydrogen, and then that would be added to the sun. And what do you get when you add hydrogen and oxygen to the sun? You just make it bigger and hotter. So you increase its mass, it has more fusion at its core, puts out more energy, and you could just keep adding more and more water. And eventually you would get to a place where you've added so much water to the sun, or added so much hydrogen and oxygen, that you're just dramatically decreasing its lifetime. And so instead of it lasting like another, 6 billion years, it's going to last 1 million years. But then it's going to explode as a supernova. So there's no amount of water that you could put into the sun that would put it out. Because it's not a fire, it's fusion, and fusion loves to get more atoms. Uğur E, what can we do against a rogue planet that is on a collision route to Earth? Nothing, right? If we determine that there is a rogue planet moving through the solar system, an interstellar planet, like a giant comet through the Atlas, and it is on a collision course with the Earth, there is absolutely nothing that we can do. The mass involved with an object like that is just enormous. It's the mass of the Earth, probably, right? Or more than the mass of the Earth. And we don't have any way to change its orbit under the sort of current capabilities. And so what do? We just get hit. Maybe we move some people off to the moon. Maybe we move some people off to Mars. But if this object is passing through the solar system, it is going to gravitationally perturb all of the planets. It's going to cause mayhem. And, one of the things when you look at the orbits of the planets and how they are, although not perfectly circular, they are roughly circular. It tells us that a giant rogue planet probably didn't pass through the heart of the solar system any time in the solar system's 4.5 billion years. That these are very rare events if they do happen. Stars get close, but not that close. Black holes probably got close, but not that close. And rogue planets probably get close, but they haven't gone right through the heart of the solar system. And so, what are the chances that this is going to happen in the future? Not zero, but really close to zero. And so it's the kind of thing that you shouldn't worry about. Anonymous skeptic. If we can look at other planets far away and then get their composition, gases, etc., what would the Earth look like from another galaxy? We can barely gather the faintest hints of information about planets that are within this galaxy. A few hundred light years away is about the limit of what we can do to really measure the atmospheres of other exoplanets. So what would the Earth look like in another galaxy? It would be impossible for us to detect. And so I think, I'm assuming that you're asking what would it just look like from another star system? Like if there was an alien civilization that was 100 light years away from us and they were looking at us with their current technology, what would they see when they tried to look at the Earth? And the answer is they wouldn't be able to see anything. That our best technology today cannot separate Earth from the sun. That the brightness of the sun is 10 billion times the brightness of the Earth. And the highest resolution telescopes that we have do not have coronagraphs powerful enough to block that light from the sun. Now, if the sunlight was blocked, then we could detect the photons coming from the Earth. That's within the capabilities of these telescopes, but the sun is way too bright. And so to be able to make those observations, we're going to need to block the light from the star to be able to make the Earth visible. And so that's going to require a coronagraph. And the James Webb has a coronagraph on board, something that blocks the light of the star, but it's not powerful enough. And so the upcoming Nancy Grace Roman telescope is going to have a better coronagraph on board. It's going to be able to distinguish Jupiter's orbiting sun-like stars, but that's not enough to be able to see Earth's orbiting sun-like stars. So it's going to require an even better coronagraph. And so there's some ideas to improve the coronagraph technology on the telescopes. And then the other idea is to launch a starshade, some kind of free-floating flower petal shaped object that flies about 10,000 kilometers away from the telescope and perfectly blocks the star while leaving the planet visible beside it. And then that's what it's going to take. The other possibility is that you shift your wavelengths into the infrared. So the brightness difference between a star and the planet is only about 10,000 in the infrared and not 10 billion. So that is definitely possible with a coronagraph. But the problem is then you need a telescope that is about 21 meters across. And of course, James Webb is only 6.5 meters across. You need a telescope that is much, much bigger than what our biggest telescopes are today. The one possible telescope that could do this is the upcoming extremely large telescope. It's going to have a 39 meter mirror. And so that is big enough to be able to resolve the separation between the planet and the star. It's also going to have a very powerful coronagraph on board that should be able to block the light from the star. And so maybe if other civilizations had built the extremely large telescope or something bigger, then they could detect the presence on Earth. And the things that they would be looking for would be chlorofluorocarbons. They'd be looking for industrial pollutants in our atmosphere. That's the clearest giveaway that there is intelligent life here on Earth. But then there's going to be able to detect other stuff, carbon dioxide, methane, ozone, oxygen, and start to build up a map of the gases in the atmosphere to try to determine if there's even life on planet Earth. But right now, with our technology, we could not detect ourselves even around Alpha Centauri. It's time to shout out our new patrons at the $5 level and above: Beatrix, John Richard Yentema, Joey Kanina, Ulfgar Nayalo, Steve, Daryl Slaughton, Christopher L. Todd, Hans Dorn, Gregory Gerdes, and Josie Moeller. Join our community at patreon.com/universetoday. Kaanboztepe, why are we not seeing a lot more observatories launch into space with the cost so reduced in the last 5 years? Because the launch costs are only part of it. And, there are a lot of missions that have been launched because the launch costs have been decreased. The cost of, say, launching a spacecraft on a Falcon 9 is, 60 million-ish, 90 million on a Falcon Heavy. In the olden days, it was 200, 300 million to launch on a Delta or an Atlas. So that's a huge cost savings. And so you're seeing a ton of missions. And there have been a lot of space observatories that have been launched on, we have the SphereX, we've got the TESS mission, we've got, I can't even go through all of the recent observatories that have been launched. Maybe you haven't been sort of watching every single one of them, but it's probably been 5 or 6 observatories a year that are being launched. And a big part of that is the decreased launch costs. It's the big ones, the big flagships. Then the launch cost doesn't really matter that much compared to it. Like the Hubble Space Telescope was launched on the Space Shuttle. James Webb was launched on an Ariane 5 rocket. And it cost $10 billion to build and then a few $100 million for the launch costs. So as you move towards a flagship mission, those launch costs become less and less relevant compared to the development costs of the observatory. And now you're in this time where almost every single major mission is either experiencing delays or cancellation. So in the US, what's the necessity of bringing those launch costs down if none of the missions are being funded? Emily Tarver, what's the most cinematic moment you've ever experienced in real life while covering space news? I watched a rocket launch. I watched the OSIRIS-REx mission take off. That was pretty amazing. So yeah, I would say that, experiencing a rocket actually take off is fantastic. I highly recommend it. And it's a thing you can experience. Like you just can go to the East Coast of the United States, go to Florida, land in Orlando, drive out to the Space Coast, go to the Kennedy Space Center, and then watch a rocket take off. They're going every couple of weeks at this point, sometimes a couple of times a week. And so your chances of watching a rocket take off are pretty high. Emily Tarver, which is harder, keeping people excited about the slow, quiet missions or the calming hype around flashy ones? I don't care. I don't care what people want to know or want to hear. All I care about is what I'm interested in, what I'm fascinated, what I'm curious about, and the things that I think are underreported or the things that I think are most interesting. And my assumption is that if I find them interesting, other people are probably going to find them interesting too. And so that's what drives my coverage. I don't spend a lot of time trying to think about what people expect, because I find then you just cave to the majority and you stop being interesting and unique. So I just I don't overthink it. If this is something that's interesting to me, this is something that I'm curious about, and so I report on it. This is something that is boring to me now, so I don't report. I barely cover SpaceX launches. We'll talk about Starship, but I don't talk about all of the regular Starlink launches that are going on, even though they're news. I just don't care. It's not interesting to me. So I've moved on. There's a lot of other stuff that I just don't report on. And so I think if you start to kind of think how is this going to be accepted? How's this going to be adopted? There are definitely times where, like with the 3i Atlas video that we did last week, where you feel this rising frustration about the way something is being covered or the way something is being sort of explained in the media. And so you feel this urge to respond to it. And so then I just follow my instincts again. So I don't have any larger plan. I'm not trying to craft some kind of consciousness about how people perceive the news or any of that. I literally just follow my curiosity, and that's it. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus, and this week's bonus question: which cinematic cliches deserve to be thrown out of an airlock? And I'll put a link in the show notes. All right, those are all the questions that we had this week. Thank you, everyone who joined me live for the question show, which we recorded on Monday. Everybody who put your questions into the YouTube comments. Now, the next live show is going to be happening on Sunday, October 26th at 10 10 p.m. Pacific time, which is going to be mid-afternoon for Australia, which is why we're doing this. So I'll put a link here, and you can make sure you subscribe to the channel, click on the notifications bell, and notify for that specific event if you want to be part of it. Now, I'm going to give you some recommendations to some cool astrophotography channels, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Barry Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Baylock, Cy Nelson, Dark Finga, Dave Verbaugh, David Gilton, David Matz, Evan Pro, Greg Feely, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Switz, Michael Purcell, OneStepForAnimals.org, Paul Robach, Brent Kaidu, Richard Williams, Sean Sargent, Stephen Fowler Munley, Team 49, Telescopes Canada, Vlad Shiplin, and Wolfgang Klotz, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So I've got some smaller channels to recommend to you this week, and I'm going to focus on astrophotography. I sort of went down an astrophotography rabbit hole and found a couple of really cool channels. The first one is one of the best astrophotography channels I've ever seen on YouTube. It's called Cosmic Captures, and the quality of just the production of the videos themselves is just amazing. And at the same time, the actual astrophotography that's being taught is also amazing. And I do not understand why the channel doesn't have hundreds of thousands of followers. So definitely go and check out Cosmic Captures. The next one is Luco Matico. And so this is a mix of astrophotography and history, sort of astrophotography told through history. So looking at the work done by Galileo or Copernicus and sort of seeing how those influence modern astrophotography, but also just practical astrophotography and what the history of astrophotography is. And then what I'm always looking for is someone with less than 1,000 subscribers. And so check out Astro Imagery. And, there's a lot of just like general astrophotography type topics, and it's been putting out a ton of videos, and yet has only got around 800 subscribers. So I really admire the dedication and the astrophotography work. A lot of practical advice on how to make your pictures look better. Now, one of those was recommended to me by a patron, so thank you. Hopefully you know who you are. But the rest of them I was able to sort of dig and follow that theme. But astrophotography is a great hobby. And so if it's something that you're kind of thinking about getting into, definitely check out some of these channels. All right, we will see you next time.